All right, welcome to the cumulative test number 2 review packet video number 2. We're going to pick up here with number 18. So when I look at 18, I notice again that I have these parentheses that I'm raising to a power here. So I'm going to get rid of the parentheses first and have negative 2 to the second power and then x to the second power because there's two bases inside. Then I'm just going to recopy everything else that I see. I next am going to simplify negative 2 times negative 2 to be 4 x squared y to the fifth times 8 x to the fifth y to the negative second. And just like a previous example, the 4 and the 8 are not like bases, but they are regular numbers. So I can multiply them as the problem asks me to do to be 32. However, I do have x squared and x to the fifth as like bases, so I'd add those exponents to get x to the seventh. And then I would have y to the fifth, y to the negative second. You could flip this, but I think it's easier in this circumstance to just add your exponents, and 5 plus a negative 2 is y to the third. So your final answer will be 32 x to the seventh, y to the third power. Number 19. These look like a true treat, don't they? So number 19, you have 1, 2, 3, 4, 5, 6 bases within your parentheses. So all of them are a power to the third here. Remember that the 3 and the 2 have exponents of 1, so we have to multiply all of these exponents within. So we'd have 3 to the third, x to the negative 12th, y to the 15th on the top. And in the denominator, we'd have 2 to the third, x to the 18th, y to the third. Please don't forget to raise that y to the third also. Very common mistake. Like previous problems, we have like bases here, and we have like bases here. However, the numbers, definitely not like bases, so all we can do is simplify and see if we can reduce them any more. So let's take care of the like bases first. X to the negative 12 minus 18th power, and y to the 15 minus 3, or to the third power. If I now wonder about the numbers, 3 to the third is not 9, it's 3 times 3 times 3, which is 27. And then 2 to the third is not 6, it is 2 times 2 times 2, which is 8. So far I have 27 over 8, x to the negative 30th power, y to the 12th power. I'd say the best way to write the final answer for this problem, if you notice that this is going to flip down, would be 27 y to the 12th on the top, because those do not flip. However, 8 stays in the denominator, and x to the 30th would join it. Number 20 is similar to number 19, except we have a negative exponent on the outside. But still, there are 3 exponents, or 3 bases, in the numerator and 3 in the denominator. So if I apply power to a power, I would have 6 to the negative third, x to the positive 6th if I'm multiplying, y to the negative 21st, over 2 to the negative third, x to the negative 15th, and y to the negative 1 times negative 3, positive third. So please just look this over. Please make sure that you have the correct signs. Make sure you have negative, positive, negative, 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 positive. So just like 19, again, I'm going to focus on the like bases first. I'm going to focus on the x's of like bases, and then I'm going to focus on the y's. So the x's would be x to the 6 minus negative 15 power, and the y would be negative 21 minus 3. For now, I'm going to come back to the bases that are not the same. So this would be x to the 6 minus negative 15, which is a plus. So x to the 6 plus 15 is x to the 21st power. And this would be y to the negative 21 minus 3 is the negative 24th power. This problem, though, again, please remember that negative exponents do not give you negative numbers. They give you the reciprocal. So what I would suggest doing is recognizing that both of these need to flip. So I did not flip here because I had like bases. I found it easier to use the subtraction rule. However, I would take the 2 to the third and raise that to the numerator, and then I would take 6 to the third and put that in your denominator. So here, if we simplify that, 2 to the third power is 8 again, just like the last example. And 6 to the third is 216. So we have 8 over 216, x to the 21st, y to the negative 24th. So two things. We definitely need to flip this down, but also 8 and 216 definitely have at least a 2 in common, and we could even check for 4. Let's even check an 8. Yes, 216 is divisible by 8. So if you took an 8 out of both of these, you'd be left with 1, and 216 divided by 8 is 27. So I think the best way to write the final answer would be as follows. You would have a 1 on the top. You would have an x to the 21st on the top. In the denominator, you would have 27 now, because you reduced that. And the y to the 24th would flip downwards, and the exponent would become positive. And no, you do not need that 1 there anymore. Feel free to ask about this in class if you'd like to. I know it's very unusual, but all I did here was I simplified the fraction. Notice that both were divisible by 8. You always want to reduce your fractions as much as possible. Number 21 is the last of the true exponent rules before we get to the scientific notations. This 21 is a good problem also because it's reiterating what the exponent of 0 is actually applied to. Please notice that the 4 is not being raised to the 0th, neither is the negative 7, and neither is the 10. So this really means 4 times 1, because just x to the 0th is 1, minus 7 times 1, plus 10 times 1 times another 1, because both of these separately end up being 1. 4 times 1 is 4, 7 times 1 is 7, 10 times 1 is 10, 4 minus 7 is negative 3 plus 10, so your final answer would be a positive 7. Moving on here to scientific notation. The first 4 examples are all not using exponent rules yet, but just simplifying to scientific notation or vice versa. So you might recall from class that I said that in order for something to be in scientific notation, it would be a times 10 to some power b, and this number has to be between 1 and 10 by definition. So if it's not, we'd have to move the decimal and change the exponent as well. So number 22, my decimal point is currently after this 0, and so we need this number to become between 1 and 10. So we'd have to move the decimal over 1, 2, 3, 4, 5, 6, 7 times to create a number that is now between 1 and 10. Because now my number is 5.2, but we need to write times 10 to the number of spaces that we moved. So we moved 1, 2, 3, 4, 5, 6, 7 times. And because my number was originally very large or big, my exponent is a positive 7. However, number 23, the decimal starts here, and notice that the number is originally small, which means my exponent would be negative in the end. So I'm going to move the decimal point 1, 2, 3, 4 places to get this number between 1 and 10, because it would become 1.7 times 10 to the 1, 2, 3, 4 positions. It's going to be a negative 4 though, because my number was originally small. If we reverse this idea and I give you something in scientific notation, I would like you to write it in standard form, aka a regular number here. So if I have 2.3 times 10 to the 4th, that means that because my exponent is positive, I would like a large number, so I need to move my decimal point to the right. So I would go over 1, 2, 3, 4 positions, and anytime I don't see a number, I put a 0 as a placeholder. So my answer would be 23,000. That is the regular number in standard form before scientific notation. Number 25, if my original number is 3.1 and it's to the negative third, that means that my number was originally small. So to make it true, I would have to move my decimal point to the left. So I would go over 1, 2, 3 positions, put zeros in as placeholders, so my number in standard form would be 0.0031. Now come the examples where we use scientific notation and the exponent rules. So what I'd like you to notice in number 26 is that we do have two parentheses representing multiplication, but we do not have a power on the outside of either one. So when we were doing exponent rules earlier, that's when we would add our exponents. And these two do have the same base, and so we would add our exponents, 10 to the 8 plus negative 2 power, which would be 10 to the 6th power. However, the 1.2 and 3.0 are not like bases, so we'd have to just multiply those as normal. So 1.2 times 3 gives me 3.6. So we'd have 3.6 times 10 to the 6th power. Over here, I can definitely write a note that I did 1.2 times 3.0 to get this. What you need to check for is this number between 1 and 10? Yes, it is. So this is my final answer. Nothing else needs to be done. Number 27, I notice again I have two parentheses, no powers on the outside. So I am going to add my exponents again on like bases. So we'd have times 10 to the 32 plus 5. So we'd have times 10 to the 37th power. Now, because 2.7 and 6.0 are not like bases, we do need to multiply them. And if I write that down, 2.7 times 6.0, that would get me a 16.2. Now, this time, the 16.2 is not between 1 and 10. So we need to change it to be between 1 and 10. And to do so, my decimal point would have to move over 1 to become 1.62. Now, as we talked about in class, as the decimal point moves over this way, it means it's farther away from where it started. So what we need to do here is have 10 to the 37 plus 1 power. Because my decimal point moved away from where it wanted to be, we really added an extra step. So my final answer will be 1.62 times 10 to the 38th power. Another way to think about it is that this is kind of opposite of what your gut instinct tells you. We're moving the decimal place to the left, so we really need to do the opposite of what you think and add here. The next examples. So this time we have division of like bases and of exponents. So I notice that I have the same base here, and when we had the same base and we divided like bases, we subtracted the exponents in earlier examples. So we'd have 10 to the 8 minus 2 power, or times 10 to the 6. Again, just like the previous two, these are not like bases, but the problem is asking you to divide. So if you did divide 4 divided by 2, you would have 2 times 10 to the 6th power. Because 2 is between 1 and 10, my answer has been done. 29, however, I do have like bases here, and if I subtract my exponents, I'd have 10 to the negative 2 minus 3 power, or times 10 to the negative 5th. But if I look at these unlike bases and treat them as regular numbers, if I take 1.25 divided by 0.2, or excuse me, divided by 2, I would get 0.625 times 10 to the negative 5th. Now, this time, this number is again not between 1 and 10. It's lower than that. So to get it between 1 and 10, I would have to move the decimal place 1 this direction this time. So we get 6.25 times 10 to the something. Now, this time, remember the decimal place really wants to be at the end of the number. So we moved the decimal place one step closer, which means you don't have to walk as far if this was you actually walking along the number like this. So if you don't have to walk as far, you subtract a step this time. Or if you move the decimal place to the right, you would subtract. So your final answer here will be 6.25 times 10 to the negative 6th power. If you'd like to continue on with the rest of the problems, there will be a video number 3. So this is the end of video 2. See you at the next one.